Hello, today we are going to be looking at two pre-calculus problems. The first one we're going to do is an inequalities and economics problem. So for this equation, the demand equation is P equals 190 minus 0.001x, and the supply equation is going to be 100 plus 0.002x. So you're going to want to do first, you're going to want to go to the y equals, put in your equations like so, highlight the y, and you're going to change the sign to be either greater than, less than, equal to, depending on whatever it is. For this equation, the demand is going to be y is less than, and for the supply, the y is going to be greater than. So you're gonna graph that up, but before you do so, press second graph and table, and you're gonna have to do a little bit of maneuvering here to find where the x max, the y max, the x min, the y min is going to be, because the standard window will not be sufficient to get your answer. So once you have that, I did this myself already, so I got the x max is as 40,000, the y max is 300. This could change a little bit depending, there's not one exact right answer. So once you have a viewing window that is sufficient, you're going to graph it up and you will get a triangular shape on your calculator like I am getting right now. If you're getting something like this, you should feel good about yourself. And next you're going to press second trace. You're going to click right one to inequality. You're going to press unequal intersection. And when you do this, you will be able to find the point of equilibrium, and this will help you out throughout the whole equation, because once you find the point of equilibrium, I should tell you, is the point where the supply and demand equations intersect, and that's like the perfect outcome that they want. So when you do this, if you did it correctly, you will get 30,000, 160, which is exactly what you want. And now we're going to delve a little bit further into this, to the consumer surplus inequalities. So what you're going to want to do is you're going to want to keep the y is less than the consumer surplus inequality on. You're going to want to go to the top where the x is, like so. And you're going to want to put x is greater than 0, because you're not going to have a negative in this problem. So x is going to be greater than 0. The next thing, which is why the point of equilibrium is important, is it gives you the y value. Now the y value for that was 160, if you remember correctly. So what you're going to do for this is you're going to go back to your equations here, and you're going to put y is greater than 160. And once you do that, also unhighlight the producer surplus inequality, and now you can graph that. And when you graph that, you will be able to now find what the consumer surplus is. Now, to find the consumer surplus, you're going to have to use A equals half base times height. So what you're going to do here is, if you did this correctly, you're going to press second trace inequality, then you're going to do point of interest trace. Now, when you do that, it will show you the 3 points of interest. Now, if you did this, you shall get 0, 160. You will get 30,000, 160, which is the point of equilibrium, and 0, 190. Now, this is a lot to take in at one moment, so let me tell you exactly what you need here. So the 30,000, that is going to be your base, because it goes from 0 to 30,000. So that's half the problem. The next you're going to have to find is the height. Now, you might be inclined to think the height is 190 because that's the highest point, but we're only looking at that triangle right now. Anything below that 160 is irrelevant. So what we're going to do is you're going to do 190 minus 160, which will give you the height, which is 30. So once you have that, you'll do A equals half 30 times 30,000, and for all you math scholars out there, that is going to turn out to be 450,000. Now for the producer surplus, you're going to do nearly the same thing, except you're going to unhighlight your consumer surplus inequality, and you're going to flip the 160 to be y is greater than, again, the y is less than 160. My apologies. And when you do this, you're going to get a similar triangular shape, and they're going to have one similar point, which is the point of equilibrium, which obviously we already know is 30,160. The next point you're going to get is you're going to have 0, 160, and you're going to have 0, 100. And much like the consumer surplus, 160 is not going to be the max. You're going to do 160 minus 100. So that's going to give you A equals 1/2, 60 times 30,000. And again, a very strenuous problem here. You're going to get the producer surplus to be 900,000. So once you do that, your problem is done. You have the point of equilibrium at 30,000, 160, the consumer surplus at 450,000, and your producer surplus is 900,000. This is the final result if you want to see it with the inequalities. And we're going to move on to problem number 2 here. For this problem, we're going to be creating a frequency distribution, relative frequency distribution, and a cumulative frequency distribution using 6 intervals. Now, it sounds like a lot at once. Trust me, it is one of the easiest things you will ever do. The first thing you have to do here is you have to do the range, and then you have to find the range and then divide it by the number of intervals. So in this problem in particular, there's 6 intervals, as it says so kindly. And then the range here, so we're going to have Germany is going to be the top at 823, and Sweden's at the bottom with 254. And so you minus that, again, another strenuous problem, you get 569, and the interval is 6, so you divide it by 6. Then you get 94.83 repeating, which you're going to round up to 95. So next is the very easy part where you're just going to create the interval. And what you're going to do here is you're going to start at the bottom, so Sweden, which is 254, and then you're going to add 95 to it. So you're going to have intervals from 254 to 348, and then you're going to start at 349 to 443, and etc. And if you did the range divided by the interval correctly, you should end up with intervals that fit all your numbers in the original numbers. And next, what you're going to do, this is a little bit of an annoying part, is you're going to find the frequency of each. So if the interval was 254 to 348 per se, you're going to find all the numbers between 254 and 348, and however many numbers are in between those, you're going to put in the frequency. In this case, between 254 and 348, there's 8 different numbers. So you're going to put 8, and the same will go for the 349 to 443, and etc. If you did that correctly and didn't miscalculate, you're going to get 8, 1, then you're going to get 7, 5, 6, 1. The next is the relative frequency, which what you have to do is you have to do the frequency, and then you have to divide by the total numbers. So the first one, for example, the 254 to 348 I go back to, is going to be 8 divided by 28. So you just want to go on your handy-dandy calculator quickly, 8 divided by 28, and you're going to get a number 0.2857, whatever, doesn't frankly matter. What I did is, it doesn't say specifically in the problem, but I rounded up to 0.29%. And what you're gonna do the same thing for the rest of them. So 1 divided by 28, you get 0.04, 7 divided by 28, 0.25%, and etc. And then this is the hardest part of the problem, the cumulative frequency. You pretty much just add up all the numbers. So the first frequency was 8, then you do 8 plus 1, then you get 9, then you do 9 plus 7, you get 16, and etc. And this particular problem had 28 total terms. So That's how many terms you should get unless you don't know how to count. And then what we're going to do is we're going to take this information we have here and we're going to graph it. And the first histogram we are going to graph is the frequency histogram. So the axis, the x-axis, should be your numbers in the interval. So the 254, and then we went all the way up to 729. So on the x-axis, like so here, you're going to have 254 to 729. And then the y-axis, depending on what the highest number of your frequency was, in this case it was 8, you're going to make a y-axis that correlates with that. So I just went up by 2s. I did 2, 4, 6, 8. And then you just draw, so the 254 there's 8, so you're going to want to draw your bar up to 8 and etc. for that. And then the relative frequency and the cumulative frequency are also very similar to that. You're going to keep the same x-axis, and then the y-axis, depending on your percents, you're going to make. So this one, the highest percent is 0.29. So I just went up by 0.05. You could do 0.1 if you want. It doesn't matter. It's up to you. So it should look something like this. They should be touching, by the way. I slacked off a little bit there. My apologies, but the bars should be touching each other. And then the last one, the cumulative frequency, this should kind of go in an upwards growth here because you're adding the frequencies together, so you're obviously not going to be going in a negative direction. So this one, there was 28 total terms, numbers, and so I went up by 7, so I did 7, 14, 21, 28. The first number was 8, so then I did 8, then I went to 9, and etc., etc., etc. And that was it for that problem. Does not seem that bad at all, right? It's just a lot of tedious work, counting numbers, dividing by, but if you have the right mindset and you get through it, you should be good to go. All right, that's all I have for today. I got an Andrew Luck jersey on. Hopefully you get lucky. Hopefully we get lucky and this quarantine ends. That's all I have for today. Thank you, and have a wonderful evening, whatever day it is. I don't know when you're watching this, but take care.